Hello everyone, this is V. Kavya, Assistant Professor, Department of Biomedical Engineering, Welltech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College. Today we will explore how deep learning is transforming neural therapy. Neural therapy additionally deals with diagnosing and treating nervous system related disorders. With advancement in AI, especially deep learning, we can now analyze brain signal, predict neurological condition, assist surgeons, and develop intelligent rehabilitation system. In this presentation, I will explain what deep learning is and why it is suitable for neural therapy and discuss major application models, challenges, and future directions. Neural therapy involves a diagnosis and treatment of dysfunction in automatic nervous system and chronic pain pathway. Traditionally, this includes nerve block, trigger point therapy, and diagnostic observation. However, as neurological data become more complex, EEG, MRI, EMG clinicians now rely on AI tools to help interpret large amount of neural information. Here is where deep learning fits very naturally. Deep learning is a branch of artificial intelligence inspired by how the human brain works. It uses neural network with many layers capable of learning pattern on their own instead of manually designing features. Deep model automatically extract meaningful characteristic from brain images, EEG waves, or nerve conduction signals. This makes them highly effective in neural therapy applications. Deep learning has several advantages when applied to neural therapy. Neural disorders often follow non-linear pattern. For example, the nature of epileptic EEG signal. Deep networks excel at learning such complexity. They also detect minute abnormality in MRI or CT images that clinician may miss. Another strength is real-time decision making help during surgeries, monitoring ICU patients, and predicting epilepsy before they happen. Different neural network architectures suit different neural therapy tasks. Convolution neural networks are used widely for interpreting brain images like MRI and CT. For EEG and EMG signal, which are time-dependent models like RNN or LSTM, work better. Autoencoders help in extracting meaningful features and detecting unusual patterns. GAN help generate synthetic medical images, which is extremely useful because patient data sets are often limited. Tumor detection from MRI or brain mapping during surgery or AI guided robotic surgery predicting surgical visits. One of the most important application of deep learning in neurosurgery. Models can automatically detect tumor, classifying them, and help surgeons plan the exact cutting path. AI also assists in real-time brain mapping, identifying functional regions during surgery to avoid damage. Robotic system guided by deep learning improve precision as safety predicting models also estimate complications before surgery. In neurological disorders, deep learning plays a critical role. For epilepsy, models detects epilepsy onset in a real time and can alert caregivers. In Parkinson disease, deep learning analyzes movement pattern to evaluate tremor severity. Stroke detection is another critical area. CNNs detect blockages or hemorrhage in CT scan within seconds. Alzheimer's disease shows subtle brain atrophy pattern which deep models identify even before symptoms fully appear. Chronic pain disorder also show unique EMG and nerve conduction signature that deep learning can analyze. In rehabilitation, deep learning helps decode brain signals from EEG and translate them into actions known as BCI stroke. Patient benefit greatly from deep learning powered exoskeletons that learn their movement pattern. Personalized rehabilitation programs adapt according to the patient's real-time muscle and nerve activity. This brings therapy closer to the patient specific model. Despite its benefit, deep learning faces many challenges. Medical data sets are limited and privacy rules restricted data sharing. Deep models often work like a black box, making it hard for clinicians to trust automated decision. Training model requires high computational power. Ethical issues like bias, fairness, and accountability must also be addressed before large scale adoption. The future of deep learning in neural therapy is extremely promising. Explainable AI will allow doctors to understand why the model made a particular prediction. Wearable devices using deep learning can monitor brain activity 24 into 7. Neural implants will restore lost function in paralysis and stroke. Personalized medicine will allow therapy plans that perfectly match each patient's brain signatures. Combining brain signals with genetic data will open new research neurobiology. To conclude, deep learning is reshaping every part of neural therapy, from diagnosis and prediction to treatment and rehabilitation. It enhances accuracy, speeds up clinical decision, and enables new possibilities like brain-computer interfaces and AI-guided neurosurgery. With continued research, deep learning will play an even more critical role in neurological healthcare. I hope this section is very helpful and thank you.